morning, everyone. Welcome to today's third team session. We have the lovely guest Ahmed from Kareem. He's one of the leaders of their Android development team, and he's done a great job to introduce the first super app in the region. He's also come here all the way from Silicon Valley to help Kareem, and he's also worked on different mobile applications for Facebook, Twitter, and Evernote. I won't take too much time. I'll just hand it over to Ahmed to show you about mobile development tools.
Thank you. Good morning, everybody. So today I just want to talk about some tips and tricks for productive mobile development and mobile development teams. Why do we care about mobile? It's because, for a lot of startups and a lot of companies, mobile is basically the way that that we connect to the customers. And it's usually a lot of people go mobile first or mobile only. Even lots of the big companies, most of the traffic comes on mobile, with very little bit of traffic going on web and other things like that. So optimizing for mobile, of course, is very critical for that. Typically, startups try to go through this kind of cycle where you start off with a set of ideas. You work on building those ideas into a product that you then ship. And once you ship the product, you try to start measuring and seeing how things are working and so on and so forth. You look at the data, you learn whatever insights there are to learn from the data, and then that in turn brings up new ideas on how to improve the data that we're seeing and start all over again. So this is kind of I think they call this the lean startup cycle. Something like this is usually kind of what happens. But really the key point here is that the faster iterations are essential for the success of a startup. And the faster that cycle is and that loop is, the more likely that you can be successful when working on a startup. Especially because the faster you ship and the faster you understand the customer's needs and the faster you can adapt to them, the quicker that you can kind of change your product and find the good product market fit and basically be able to bring success to the startup that you're working on. So let's talk about some factors affecting speed. One of the first things to consider is distractions, which sounds kind of strange, but this comic explains it pretty well, and I know it's a bit hard to read, but basically this person is thinking of how to solve this problem. They're doing all these complicated formulas in their heads, and they're tracing the code and tracing the code and tracing the code until someone says, hey, so I just sent you an email about that thing, and then it all just vanishes. And then once they try to focus again, they have to start all over again from the beginning. But this is a bit exaggerated of a joke. This is actually the case a lot of times for engineers and developers working on things. A second factor is communication problems. And again, to illustrate, I'll use this comic where he's asking what's the estimate? A month? What if we had another engineer? Then 2 months? What if we had a PM? You don't even want to know. So, again, a bit too much in terms of the joke factor, but there is some reality based in this. A third one, which is a real one that you often see at companies, is conflicting priorities. So, this is high priority, and we need this one on priority 2, and this one, let me guess, it's also high priority, so we understand each other well. And that's actually, a lot of times, that's actually what happens, especially startups in an earlier phase. And a fourth one, which we'll be focusing on a bit through this talk, is technical debt. And technical debt is defined as any time you sort of take a shortcut and implement something in the wrong way, intentionally in order to save time. And when you do this, you're making a conscious decision to basically take on some technical debt that you know that you will have to repay in the future. And the problem with technical debt is repayable with interest. It doesn't just pay back. You don't just have to pay it back as you borrowed it. The longer that you wait to pay it back, the more you have to pay it back, basically, because it keeps conflicting. So, let's fix this with a temporary solution, but that will create more problems in the long run. Yes, but we would have changed jobs by then, so it's not our problem anymore. But this is an actual issue. Another one is production fires. And this is especially in the earlier days of startups, and not even that early days, to be honest, until the engineering pipeline is kind of mature, there's going to be a lot of production fires. And that's kind of the case where I've released something to production, everything is good, but then suddenly, oh wait, something is broken in production. And so while I'm supposed to be fixing or implementing this new feature that's going out to customers next week, I have to stop what I'm doing and kind of tackle the issue that's happening in production. And we like to joke about this as engineers, but basically coworkers watching me deploy a small fix on a Friday, get ready, he's about to do something stupid. And that's also actually true because especially the one of the big problems of hot fixes or bug fixes that are in production is that they have a higher likelihood of themselves containing bugs because they've gone through less scrutiny and process and so on and so forth. Another one is hardware. So sometimes companies will say cheap out on machines for the developers, and this actually slows things down a lot, sometimes by massive factors. One of the ones we really like is number one programmer excuse for legitimately slacking off: my code is compiling. So, but really, like a lot of the builds, even when we're not even talking about, I think a lot of us can imagine that a huge company like Facebook or Google and a lot of these really big companies with huge apps, you can imagine like, oh, of course it'll take forever to compile, maybe an hour or something. But even smaller companies, it can easily take 10 minutes to compile a code base or 5 minutes to compile a code base. And hey, if you can cut that in half, that's a big part. But aside from those kind of like people-related things that slow development down, there's also process bottlenecks. The first is a company release process. So when the company comes and says, before every release, we need to sit down and get a review of every feature before we can push this out, and then we'll see what goes in the release and what doesn't. That typically always slows down the release, and the release never ships on time. And actually on that first point, at Careem, we used to have this. So we used to have in one of the apps that we were shipping, the release process was usually 2 weeks. They would work on features and stuff, and then at the end of the 2 weeks, they would come and say, hey, let's get together in a room with the PMs. The engineers would demo the features, and then the PMs would look and say, go, no go on each feature. Sometimes they'd say, oh, tweak this, wait till the next cycle, so on and so forth. But this cycle inevitably added a lot of overhead. Not because of the meeting itself, but because of the action items that were like, no, we absolutely can't ship until we take care of this, and this. Go do that first. And then instead of shipping after exactly 2 weeks, you end up shipping after 3 or 4 or whatever. Another one is the App Store review process. So when you're shipping a mobile app on the Play Store or on the App Store, you are subject to the review process. And while both Apple and Google are typically pretty good about this, there are no guarantees. And sometimes, we've seen apps get approved within like an hour, and we've seen the apps get reviewed within 3 days and not get reviewed. And there's no guarantee. And on Google, you can't really expedite. You don't have a way to expedite. On Apple, you have a one-time expedition, which may or may not work. Because from friends who have apps on the App Store, sometimes you'll expedite, but it'll just be a really busy time anyway. And so you move higher up in the queue, but it still takes 2 days to get your review in. Tied with that is the whole rejections thing. And sometimes you get rejections for completely random purposes. Rejection doesn't mean that you've done something wrong. Sometimes the process itself goes wrong. Personally speaking, I've had one of my apps that's been in the store for many, many years. And one of the times I submitted, and they said, hey, copyright infringement, you stole this icon. I'm like, I've been using the same icon for like 7 years. And of course, I have to start an appeals process, and I had to prove to them that this was the icon of the app from N years ago, and they let me through, but that took a week. And so these are all process bottlenecks that also go through. And the final one is adoptions take time. And what I mean by that is, today, we push an update to an app. You don't have 90% of your users on it tomorrow, or your customers on it tomorrow. A week from now, you still won't have 80%. Depending on the app and depending on this, adoptions always take time for people to adopt the new versions. And so a lot of the focus of this talk is going to be on optimizing the build area, and I'll talk a little bit about the measurement and learning area as well, but mostly I'm going to be focusing on the building area and some tips and tricks around that. The first one that I want to talk about is experiments and toggles. And so a lot of times, especially earlier on, you decide like, hey, for the product we need this particular feature or this particular thing. We're going to build it. And maybe sometimes designers will come up with two completely different implementations of the feature and or like kind of designs and say, hey, which one does the team think is better? Should we go with this one or this one? And so at this point in time, like in an ideal world, you could just do both and see which one works better. But if they're completely different and you're strapped for resources and cash, as most startups are, you need a better way to decide on a direction. And the recommendation here is to ask the customer. So to run customer studies. And if someone hasn't done this, if you haven't done this, like as in either a participant or if you haven't participated in one of these or given one of these, it's a very, very insightful thing to do. But I think the key points are, the first point is you are not your customer. And so a lot of times engineers especially or product people working at startups or designers are like, hey, I'm one of the people who uses my app, so I'm a customer. I can intuitively say what works and what doesn't. That's completely incorrect, because by nature of working in a tech company or in a company building tech products, you already have a level of experience of tech experience that's not there for the rest of the people. And so don't rely on your kind of intuition on these things. So how these usually work is you have wireframes and discussions, maybe even the wireframes built by the design team themselves, where you prepare you basically prepare a set of things that you're trying to understand from the customers, and you start asking questions. So typically, something that could happen is like you show a design and you say, hey, you want to see how long this process took. What would you do? And then they would say, well, I guess I would do, it doesn't have to be a complete app even. And then the customer would say, I think I would click on this button here, or I'm not actually sure what I would do, or I would do this, and based on these kind of answers and the way that the responses come from the customers, you can tell about the lacking parts of your design and what's not. So kind of think about the target goals of this kind of design and ask questions accordingly and see what happens, and compare that from the first one and the second one on a set of people, so you can kind of see what ends up working better. So that's kind of the case where things are completely different. What about the case where things are they're just small variances, where you really can test both? And so imagine the case of like, I think this button should be green. And then, the CEO says, no, it should be blue. And then, or I think it should be at the bottom of the screen, and someone and says, no, it should be at the top of the screen. And so really the answer to this is to look at data, because data can kind of tell us which one works better. And especially since we all know that 72.31% of all statistics are made up on the spot, including this one, the main point is data wins arguments. And so we can sit and say my word versus your word for a long time, but really data at the end of the day speaks louder than any of us do. So really, in order to be able to do this, we need to be able to understand and monitor customer behavior. And so one of the biggest tools that all startups should invest in earlier on is dashboards. So you think about the kinds of things, the kinds of metrics that are important to your business. If it's an e-commerce app, for example, it's the number of people who eventually make a purchase. That's one of the things. But it's also the number of people who go to the shopping cart, and the number of people who who go from a product page and click add to cart, something like this. So critical business metrics, conversion funnels. And that just means how many people drop off. So for example, in an e-commerce app, I open a product page. What percentage of the people who open the product page add it to cart? And what percentage of people who go view the cart actually go to the payment screen? And how many of them actually pay and what don't? And monitoring these is really important because, for example, you might have a, say, 50% conversion rate on one of these steps. But you push out a new release, and then suddenly, you realize that, oh, this conversion rate has gone down to 25%. That means you've introduced a major regression or a bug. And maybe it's not obvious because maybe it's not a crash, but there's a major issue that needs to be fixed. And so these dashboards you need to be able to slice these dashboards by application version and be able to have alerts on them as well, so that you can know when something goes wrong. Because a lot of times, only the visible things, we find out when something goes wrong in the visible way. Oh, I launched the app and the app crashes. Okay, it's a very simple thing because the app crashes. If the world were that simple in all the cases, things would be a lot easier. Unfortunately, that's not what happens. Usually, sometimes, of course, it crashes, of course, but sometimes it'll only crash for a certain small percentage of people, or sometimes the screen just won't load, or something like this. And what exactly happens, you need to have kind of metrics in order to be able to tell. After that, once you have these dashboards and metrics, you can kind of start to run experiments. And essentially, you choose some percentage of the population, maybe you say 5% of my customers, something like this, and you say this 5% will get the new feature, and the rest of the people get the existing feature, or get this variant, and these people get the variant. Or maybe if it's a brand new thing, maybe you say 5% on this, 5% on this, 90% on the whatever was there before, and you look at the metrics and you compare. Of course, you have to be aware that, you know, the numbers you see when you ship out to 5% for anything, for crashes, or metrics for experiments, for anything, are, of course, like, it sounds logical and common sense, but it's actually, in practice, it's actually a bit more elusive than this. But you kind of start to think of the numbers, the small percentage, as the same as you think about numbers in scale, and you can't do that. So for example, if ordinarily 50% of the customers do X, and you say, okay, you launch your experiment, and then suddenly you see, oh, 75%, it's a success. No. But I have like 500 people using it. No, still no. You don't have enough data to make that judgment call yet, because that 5% population is very small. You might not even have the full, you actually guaranteed not to have the full 5% when you start rolling out, depending on how you're assigning the percentages. So you need to have like confidence, statistical confidence, that this actually makes sense before you make a decision based on the data. So don't get into the trap of like just looking at the raw numbers without having statistical confidence. But despite all of this, so you're building and you're shipping and you're measuring, but problems happen, right? In production, unfortunately. And how you deal with these problems, you have a set of options. The first is to ignore it for now. And that's typically the case for smaller issues, right? Like, oh, there's a typo on a very hidden screen that's not very prominent. I can wait and fix it in the next cycle. But if it's something really major and affecting the business and critical, you probably need the hotfix in production. But keeping in mind that hotfixing in production is problematic because, like we said before, one of the bottlenecks are the process bottlenecks take time. So releases take time, adoption takes time, and it's risky because every time you, like we were saying earlier on, every time you fix a bug, and especially under pressure and without a lot of time to kind of review and figure out if it works pretty well or not, under the deadline of deadlines and pressure and a production issue happening, you introduce more bugs. And so 99 little bugs in the code, 99 little bugs, take one down, patch it around, 131 little bugs in the code. And that's actually the reality. So what if instead, what if we can just turn it off? So, and that's when we come to talk about feature toggles. And the idea here is that for any particular feature that we ship to production, we have some way from the backend, from Firebase toggles, from our own backend server, from some third party that we use, to be able to get a list of features that are enabled and disabled. And even if we're not experimenting, we know everybody should get this, but to be able to turn it off. And of course, you can't do that for everything because, for example, the home screen, whatever the home screen of your app is, you can't toggle that off, right? Because if there's a crash on the home screen, you're in trouble. You're going to have to fix it anyway, right? But at least if you have these feature toggles, then oh, I introduced a new feature that's linked off of the profile screen, and it's crashing for everybody who goes there. Maybe if it's not a business critical feature, instead of taking the risk of hot fixing, I can turn that feature off, fix it, and then in the next release, I can ship the update. So things to be mindful of and to keep in consideration, the effect of experiments on one another. So this is actually a bit, especially when you have more and more experiments, this is actually a tricky one because one PM in one part of the org is testing an experiment, another PM in another part is testing a different experiment, and those two might actually influence each other somehow. Forgetting even the data effect on each other, but even the user experience. So for example, one thing says, okay, I'm turning this feature on or off in the profile screen, and the other feature says, oh, I'm turning on a new profile screen that's experimental, or I'm turning it off. And if those two are running at the same time, you can see how they can conflict and cause issues with both the data and with the customer experience, where you get into a situation where the feature doesn't show up, the feature doesn't launch, or some other problems like this. Similarly, the effects of feature flags on each other, same exact point as the first one, but with feature flags instead of experiments. And one more thing is that dead experiments increase technical debt. And we've seen this a lot. So typically, you're saying, oh, I'm going to test between these two flavors of things. You write 100 lines of code for this, and this 100 lines of code is for experiment A, and the other path is experiment B. And after it launches, you say, okay, you know what? I'm killing experiment A. And then so you turn it off. And then you say, just in case, I'll leave it. Sometimes the product says, just in case, leave it. We might change our mind later, which is a problem. They never change their mind. It just always stays off. And source control, you have source control for that. You can get it back if you remove it and you need it back. But typically what happens is it stays in the code base, adding technical debt. So it adds to the build times, and it adds to the cognitive overhead when you're trying to figure out who's using this, can I remove this code or not, or what's going on. It increases technical debt. So I want to take an aside here and talk a little bit about data. Because we talked a lot about gathering data for experimentation, blah, 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 and this is all great and important. But to kind of be doing due diligence to the topic, we need to take a step and talk about data. So a couple of odds and ends about data that need to be considered, and each company needs to consider this per their needs and uses. But the very first thing is building trust with customers. So you ever download one of these apps, random apps, where you download an app and it's like, I want access to your photos, and you're like, this app, why does this app even need access to my photos? Or I need access to your contacts, or I need this or that. Or ever download an app which spams your entire address book saying like, hey, such and such person has just joined service X, like you want to join as well? And so building trust with customers is really important, especially because, and we'll come to this in a bit, especially now with some of these things being more visible, right? And that brings to the second topic, compliance. So a lot of times, you're forced into different types of data compliance by different sources. The first is the app stores. And the most recent of this is what Apple did last year and Google did this year, of kind of forcing applications to give some kind of a nutritional health label, for lack of a better word, on every app, saying what it does with the customer's data, what it does with privacy, and what it doesn't, and so on and so forth. And believe it or not, people are privacy conscious, and even if some percentage of people are not, as time goes on and more and more people are talking about this, and companies are actually taking efforts to do things like protect company data, because now it's become a competitive advantage to protect your company data. This is something you have to be aware of and have to be cognizant of. And the second is governments. We all heard about GDPR and saw those annoying banners at the bottom of web pages saying like, hey, do you want to accept cookies or not? But sometimes compliance comes from governments. Sometimes it comes from app stores. Like I said, besides just this thing, the other recent one was Apple enforcing that anyone who has accounts be able to request the deletion of all their data. So kind of GDPR, but for everyone who has an app on the App Store. But the thing about these policy changes is they're often a surprise. You're not expecting it. You're going along working on your Q2 roadmap and shipping your features, and you need to reach this target at the end of the day and stuff like that. And then suddenly it's like government regulation, App Store regulation comes down, and you have to drop what you're doing and take care of it, because otherwise you can find yourself in trouble. The next point about data is if you're not paying for it, you become the product. And I think this is a really, really important one. We've heard it all a lot about, and we know how, I'm sure a lot of us know how like a lot of the tech companies will take the data from what customers are doing on the platform and use that to keep improving the platform and bringing more people back and so on and so forth. And really the reason this is applicable for startups mostly is as companies grow, so does the value of its data. And this is a really important one that I think a lot of companies might not realize until a little bit later, until it's a bit too late. So you always have this conundrum of like, I need something. I need analytics. I need feature config. I need experiments. Do I build it, or do I buy it, or do I rent it, right? And there's a lot of these services will say, hey, we'll give you a platform where you can do your experimentation. We'll give you a platform where you can do feature configuration, and so on and so forth. At a young scale, at a small startup scale, that makes a lot of sense. because your time is more valuable than anything. You don't have money, and you're very small. You don't have many customers. You don't have many users, and you don't have the luxury of even taking one engineer's time to work on building something full time. But as you grow and become into a larger scale, at some point in time, you might be paying X dollars a month for a contract, but the data that you're giving to the customer, to that company, is much more valuable than the X dollars a month you're paying. So that X dollars a month for the company is kind of like a cherry on top. It's free money for them. Really what they care about is the data, because they take your data and they make their product better, which makes them able to kind of push their startup forward. And sometimes that's at a bad expense to you, because that company could then turn around and take that data and use it to kind of compete with you, for example, or put you in a situation where someone else can kind of build from their data and kind of put your startup in general in a bad situation. So just something to keep in mind. As the company grows and you have more and more money, you're more tempted to go with the route of like, oh, let me just buy this, or let me just rent this or pay for this. But sometimes that's not the right thing to do. Always think about the data and where the data is going. And a quick point before we move on from data, when I was talking about these compliance issues and where data goes and stuff like this, it's important to understand, especially the earlier on. So if people are just building startups now, try to build with this kind of understanding in mind. Where is this data going? What data is going where? It might sound completely ridiculous. Why do I care who's getting what? But especially keep that in mind, because some of these kind of country regulations that are happening are sometimes a country will come and say, any person in my jurisdiction or in my country, any customer in my country, none of their data can go off soil. And that's actually something that's happening in the MENA region today. So you have to make sure that you can't transmit a phone number, a location, something off-site of their servers. And now imagine if you don't know what data is going to whom. Which data is going to a third party like Braze or Firebase or this or that. Now that problem becomes significantly more difficult. How do you solve it? So I want to move on and talk a bit about structures and methodologies, which sounds a bit vague because it's intentional. And I'll give you a spoiler ahead of time. So I'm not going to give you answers. I'm going to give you questions here. So the first one is, how do we structure teams? What's the right way to structure teams? Some people say, we'll have a single full stack vertical teams. And what I mean by that is you have a single team responsible for something like search. And that single team consists of backend engineers, front-end engineers, and Android developers, iOS developers. And they all work together. They're always working on the same kind of feature, shipping the same feature together in parallel, in tandem, and so on and so forth. And the second kind of approach is sort of splits between front-end and back-end. So you say, you know what, I have a mobile engineering team for the search experience, or for the app in general. And I have back-end teams. Maybe at the beginning, it's usually one team, one back-end team, one mobile team. But as time goes on, maybe the back-end has had to grow faster than the mobile team. So maybe you have 5 back-end teams and 1 mobile team. And then the mobile team, depending on the feature they're working on, they might be working with a different one of the back-end teams depending on that feature. So which one of these should you do? Like I said, spoiler alert, it depends. There is no one thing fits all. And really what you need to do is evaluate and see what's happening and adapt to it. Sorry, I should have said adapt, but I said adopt, but oh well. But adopt. Actually, don't adopt, because you are not Spotify. So, and the reason I say you are not Spotify is because there's this thing that many of you might have heard of. You will come across it for sure working in the field, is the so-called the Spotify model. Spotify model is some kind of set of rules that Spotify came up with about how to arrange mobile teams into squads in such a way that any mobile team could work on any part of the app or any different app that the company owns in a very good way. They have very good kind of goals behind it, and it's worked out really, really well for them. But the reason I put an explicit slide, you are not Spotify, is because a lot of companies will read this kind of manifesto of what Spotify does and says, we'll just implement Spotify's model and we'll be good to go. And they do that and it fails, a complete failure. And that's why I'm saying you are not Spotify. So kind of think about what fits for you. It's good to read and understand what other companies are doing, understand what Spotify did, and understand what other companies are doing. and kind of learn from that and find your own path. But don't just blindly try to copy something because it'll fail miserably in most cases. So should I use Scrum? Should I use Agile? And again, the answer is it depends. But I do want, just as food for thought, I do want to share this chart, which I know is a bit difficult to read. But basically, it tells you that all these big tech companies on this list are Amazon, Apple, Facebook, Google, Netflix, Uber, Shopify, and so on and so forth. None of them actually use Agile or Scrum. Typically, the way things work is people will write some sort of plan about what they're going to implement. They'll build it, and they'll ship, and they'll iterate. And that's it. And by the way, like, I guess I will share these slides later so that people want to look. The source of this article, the article of this source, if you're interested, especially in Agile and Scrum and things like that, I highly recommend the article that's linked in this source because it goes into a lot more detail about why this is and what these companies do and when Scrum really makes a lot of sense and when it works and why a lot of these huge rollouts of Scrum into companies might not be the best thing. So how about interaction? Like how do teams interact in projects? At a smaller scale, in simpler times, every team has an engineering lead, and engineers just go and directly talk to each other, right? But as companies grow and grow and grow, and you have like a lot of teams involved, in order to ship this product, I need feature A from this backend team, feature B from this other backend team, and then I need the mobile teams to do this, and I need the other mobile teams to do this, and I need da-da-da. In this case, you have some sort of a TPM project lead to kind of coordinate between the teams and kind of help there. And again, same article that's from the first article. I highly recommend reading it. But really, the summary here is that communication is key. So in order to have a successful org, you need to have good communication between the parts of the organization, between engineering and product, and between product and management, and so on and so forth. One of the good ways to do this, and more from more of an engineering aspect, is RFCs. And so this is kind of the idea. And I mentioned before when I said those companies are writing some sort of plan, that's what an RFC is. RFC stands for request for comment. And it's a way that engineers will write how they're going to build something, how they're going to go about building it, how they're going to tackle the problem, how they're going to solve it, in what way before they actually build it. Why is this important? It's important for several reasons. First off, if you have a tiny team with like 5 engineers, 2 engineers, 3 engineers, you don't need this initially, right? Because you're sitting next to each other, you're talking to each other, you can't work without direct communication with each other. But scale that up to 10 engineers, 15 engineers, 20 engineers. Now you're not talking to everybody else. You're only talking to people directly on your team when you have something to talk about. And the rest of the people you only talk to every here and there. The nice thing about the RFC process is it opens up a door for people that are working on the same thing that you're working on to kind of look and give feedback. Oh, by the way, we've tried this and it didn't work. And the reason it didn't work is A, B, C, D. And so then you can say, but we wanted to try this other technique, but we didn't have time. And so then these people the team can save a lot of time. You imagine the amount of time saved by not going down a road that you already know is a dead end, right? Or we want to build this feature, it's going to help blah, 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 and be like, by the way, we've already built that. Oh, really? Can we just use it? Yeah, adopting it is much simpler and easier than building it all again from new. And so RFCs are very useful for these kind of things. And as the company grows, should aim to have RFCs for any major thing that's being developed. So shifting gears a bit, I want to talk a little bit about structuring code. And I think if I had to summarize structuring code in one word, it's modularize. And what I mean by this is that a lot of times, especially when you're building mobile apps, you start a new project, an Android project, and you have this app module by default. And the natural tendency is I'm adding everything to the app module. Or you create a new iOS app and you start adding code directly in the application module. That's a natural thing to happen. That's not a good scalable approach moving forward. And the idea is you should modularize. And modularizing, just think about it this way. Well, actually, I guess I'll get to it here. But define a set of rules. So, for example, say first off, when we say modularizing, what are we talking about? Same thing as like anything that's a major feature on its own or a major piece of logic that should be on its own should be in its own module, in its own library, in its own compilation unit. So something like, think about something like a profile feature, the profile screen. That should be a module. Maybe more than one module, but at least one module for a profile screen, at least one module for a search screen, at least one module for a home screen, and so on and so forth. You have a module for any feature, and a lot of times multiple modules. So the first thing here to do is define a set of rules. And what I mean by a set of rules here is, say for example, I'm going to split my modules into these types at a high level. I'm going to have features, which are literally just UI features that people are going to see. I'm going to have, for example, library, which is shared components between different features and so on and so forth. I'm going to have core, which is a set of like core things that everybody needs to depend on for something or another. And maybe I have like design for common, like the common styling for the company or whatever, common theming, whatever it is, but define a set of rules. So for example, one of the rules we set at Kareem is that no feature should directly depend on another feature. Now, of course, that does not mean that a feature cannot talk to another feature or cannot communicate. It just means that it cannot be tightly coupled. And the reason you don't want to tightly couple them is so that if you make a change in one, you don't want to change the other. You want to isolate, you want to make your changes as isolatable as possible, because that has a lot of benefits to it. And that's basically what this means, splitting the API and implementation. So instead of just having a login screen, a login feature, you might have a login API and a login feature that implements that login API. Why is this useful? Several reasons. First off, better isolation of features, which I alluded to before, which is you change the search feature. Why do you want to go and why do you want everybody who talks to the search feature to have to change? That adds a lot of overhead to you and a lot of overhead to the team. Isolating it is better. Easier sharing. So now this search feature and all its code is modularized, and suddenly tomorrow I'm like, yeah, I want to try this other, I want to ship another app that's kind of tangential to this business. Maybe I can share some of this stuff. Well, now it's very easy to share, because the other problem with putting code all in one place is even if you try very hard to organize it into folders or packages or whatever, it's still, you still have the tendency, you will definitely, without a shadow of a doubt, parts of the code will still refer to other parts of the code in the same thing. You'll be like, oh, I need this file. Oh, it's from the package that's 2 folders up or whatever. Like, there will be, it's going to be spaghetti. That's what it ends up being. It's spaghetti, right? Where you don't have a clear separation. What you want is you don't want spaghetti, right? You want things to be separate so you can be able to box, a box of stuff here, a box of stuff here, a box of stuff here, and these things are connected. Another advantage, faster build times. And this becomes an issue as mobile apps grow. Build times become a big issue. When you modularize, that helps you speed up the build times. Why? Because the compiler tries to do as little work as possible. And so if the way you've structured your app tells the compiler that it is guaranteed that when it compiles this, it's going to have the exact same output with or without a change, it's not going to recompile it. It's going to say use the one that was there before. So compilers are smart. They try to do as little work as possible. They say, you didn't change anything in the profile module. I'm not going to build profile again. I'm going to use the one that I already had from before, that I built last time or whatever. So you get faster build times. A really, really nice feature that I really like about this also is the ability to stub implementations. Now, what does that mean? So think about you're building an app that, for example, has a profile screen, and you have engineers working on this profile screen. Now, ordinarily, this profile screen needs to get some sort of customer object, user object, and that user object has all the data for the user, the phone number, the email address, blah, blah, blah. It has a way to update this information, so on and so forth. What I mean by the ability to stub implementations here is I could literally just say, you know what, I have a fake user object store, because now I've separated out the implementation, the API, so I can have a fake one, a fake user data store, for example, that never goes and talks to the server, never goes and talks to the backend, and it always returns the same person. It always returns a person, John Smith, this birthday, whatever, blah, 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 and it returns that information, always the same. And when you update it, maybe it updates it locally. And what that does is now you can kind of run tests, or you can or you can actually develop against this data without the overhead of having to talk to the backend. Now think about if you're building something that involves money. You need to test the purchase flow. And if every time you hit the buy button, some kind of credit card transaction needs to go through if you're testing in production. If you're testing in QA, yes, there might be some kind of QA card numbers and testing and some workarounds that are done on the backend to solve this. But you make life a lot easier for developers if you don't talk to the backend in the first place. Let me test what happens if the credit card fails. And you just change the value to failed, and you see it failing. You change the value to success, and you see it succeeding, and so on and so forth. So this opens up a lot of flexibility, and it also opens up the door to faster testing, which we're talking about, and standalone apps. And so what I mean by standalone apps is, again, if I'm working on the profile screen, instead of building the entire app every single time, let me just have a tiny app that's nothing but the profile screen. And I'm not going to include anything except some stub that always returns the customer data like we talked about, and that's it, khalas. I don't need anything else. And so I make the compilation time much faster, which means engineers can iterate faster, which means you get results faster, and so on and so forth. Shifting gears, let's talk a little bit about sharing code across platforms. So inevitably, you're building apps and you start thinking and saying, hey, I have an iOS app, I have an Android app, how can I save some time? Like, do I have some options on sharing code? Like, do I really have to write all of this stuff twice? And so when we talk about sharing code between platforms, we really have two kind of, I'd categorize them into two kind of categories of ways that there are. The first is frameworks that handle everything for you. And these are kind of frameworks that you adopt the framework, you build against the framework, and so on and so forth. It'll handle everything, including the UI for you and everything. And then kind of what I'll call do-it-yourself tooling. And do-it-yourself tooling gives you the option to pick and choose where you use multi-platform, for what exactly you use it, and so on and so forth. So let's dive in and talk a little bit about some frameworks that handle everything for you. One of the most well-known ones is React Native. And the way React Native works is your engineers write code in React, and that code basically goes through a JavaScript bridge at runtime. So there's a JavaScript interpreter that ships with your app that interprets the code that's written, and then it renders on the screen accordingly. Typically, this renders natively, hence React Native. And what I mean by that is that, for example, an image tag will end up getting rendered as a drawable on Android, or as a UI image on iOS, or whatever, something like this, or canvas operations to directly draw. You know, one of the articles that I would recommend, though, before diving into React Native is read this 5-part series about React Native at Airbnb. It talks about the rise and fall of React Native at Airbnb. They used it, they heavily invested in it for so many years, and then they ended up abandoning it. This 5-part series talks about it. The next one, which is a newer one, is Flutter. It's only recently in the past couple of years. And what it does is it's kind of very similar to game libraries like Unity and things like this, where you write some code, and then before you ship the app, it'll compile this code down into some format, and then it'll run it through, again, some sort of library that you're attaching with your code to translate everything to what it eventually draws. It's drawing both on Android and iOS with Skia, which is what iOS and Android natively draw with anyway, at some level or the other. So that's the second option. So there are, of course, others, but those are the biggest two that people are going with today. And if you go with one, you should go with one of those two, because those are the two that you will find the most documentation about, you'll find the most people talking about, so on and so forth, if you decide to go with a framework that handles everything, that is. Personally speaking, I don't like the frameworks that handle everything, but let me talk about the pros and cons to tell you why. The pros is it's potentially easier to hire for. So especially in the case of React Native, there are lots of React developers out there. And maybe finding mobile devs is difficult. Maybe you can find web devs easier, potentially easier to hire for. The reason I say potentially is because, again, market changes, but also because I'm not sure how easy it is to hire Dart developers for Flutter, for example. The second pro is write once, use everywhere. So you write the app once, and the same app, you have a shipping iOS app and a shipping Android app, which is really great because you get to save a lot of this time. One of the big advantages is faster development. So we talked a lot about how compilation time is an overhead for native mobile apps, especially the bigger they get, and you have to kind of modularize and use all these techniques to save the time and not take a lot of time. Well, these guys have something even better, which is hot reload. Because it's kind of it's web tech at the end of the day. As you're making changes, they can immediately show you the changes, so you don't have to keep to wait on a build process or something like this. And finally, it gives you the potential for hot loading code, which means that theoretically, after you ship the app, you could download some newer version of some files and suddenly update the app without actually updating the app for everybody else in the stores. Some of the cons. First off, even though in theory the code that you write gives you an iOS and an Android app, the reality is that you still need to explicitly separate out iOS and Android UI logic in a lot of these cases, especially because the UX, the user experience on iOS developers people on iOS are used to a certain type of user experience. People on Android are used to a different type, and if you try to ship one on the other, people will feel that something is wrong, something doesn't feel right. And even if you do all this extra work, it still doesn't feel native. And a lot of times when you use an app, you can sometimes tell this doesn't really feel native. And in order to completely hide that from people, you need an insane amount of work to actually make it feel completely native to people. The other major con is that new platform features are very difficult to adopt. So what I mean is, WWDC was just a few weeks ago, and they announced these new tracking widgets that'll happen soon. When that happens, if you're a developer that's building a React Native or a Flutter app and you want to use this, you won't be able to use this unless you either build it natively, or if you want to be able to access it from React Native, you're going to have to be able to build something and build some sort of wiring so that the React Native code can talk to the native code, or you're going to have to wait until it's supported natively by the framework. And then there's the overhead on binary size. So because with React Native you're shipping a JavaScript interpreter, because of Flutter you're shipping the Flutter library, these all add a sizable overhead on binary size, and this really matters because the application size does matter. I guess we'll touch on app size in a bit, but finally, rejections are likely. So you can just go on Google and search for React Native app rejected, something like that. The reason for this is that the rules around hot loading code and what you can and can't ship and so on and so forth are intentionally left vague, both by Google and by Apple. And so you never know which side of the line you're on, and suddenly you can find your app being rejected and having to go through an appeals process in order to get it to go through. One last thing which I didn't add here, but I want to point out also, is that if you decide hey, I'm going to do React Native for a part of the app and the rest I'm going to build native, or Flutter for part of the app and the rest I'm going to build native, interoperability with native code is not easy. It's a pain. How to do it is painful. A lot of times it involves serializing data into strings and passing them back and forth, or serializing and deserializing back from JSON. It's just it's a hassle. So let's talk about the tools where you do it yourself, kind of do-it-yourself tools. The first one, and I don't really recommend you use this, but well, unless the use case makes sense, we'll talk about it. C++. And basically, the idea is that Apple, you can write C++ code, Objective-C. There's Objective-C. You can ship native C code or C++ code in an iOS app natively. Similarly, using JNI on Android, you can ship C++ code. So the idea is, let's write some shared logic in C++. The pros of this are it's very high performance because you're close to the metal. You're directly close to the hardware. You're not going through the frameworks and anything. You're minimally going through the frameworks, I should say. And so you can kind of get the highest performance. Another benefit is it's easier to obfuscate code. What I mean by that is, let's say, for example, that you talk to a service. Like say you have an API key for something. Anybody who really wants to can get that API key just by having your app. So pull an Android app, run the strings command on it, and poof, it'll show you in plain text what the strings are in that APK. even if it's native code, you can just extract the native library and run strings on it. And strings is a built-in Unix command that's there by default, and you know all the strings that are there. So an API key is very difficult to hide if you just add it. And so if you just add it in this no matter what you add it in, it's very easy to find it. But if you add it in C++ code, you can actually do it in such a way that's kind of impossible to kind of see without doing a lot of hard reasoning about the code. So C++ is very, very easy to obfuscate in a way that makes it almost impossible for anyone trying to reverse engineer it. Not impossible, but just takes too much time to be worth it. And so, for example, someone wrote a blog post some long time ago talking about how Facebook does their certificate pinning, for example. And they did that in native code. And the reason is because they know that people are going to try to figure out what does Facebook do. They're going to take their applications and extract them and try to figure out what they're doing. By putting in the native code, the person who really wanted to do this has to spend a lot of time trying to understand how it's done, and the person wanting to exploit it has to make more effort to be able to exploit it. But now let's talk about the cons of sharing C++ code. C are difficult. That's why most people don't use them today. I mean, they're still used for extremely high performance things, but even that, to be honest, I think my guess is going away in favor of more safe languages like Rust. It's difficult to do correctly. It's very easy to shoot yourself in the foot, very easy to open up buffer overflows and to leak memory and all this kind of stuff. Difficult to hire for also, I should say. You still have to handle the differences between platforms because, again, like Android and iOS are, at the end of the day, two different operating systems. And yes, you can run C code here and there and C code there, but not all the API calls are going to be the same. So you still have to handle these differences. And you need a custom development environment for it, right? Like you can't just, engineers can't develop in what they're used to developing when you kind of have this kind of solution. If you're interested in using C++ in parts of your app, I highly recommend this blog post from Dropbox about the not-so-hidden cost of sharing code between iOS and Android. Dropbox was very heavily invested in sharing code in C++, and now they're kind of moving away in favor of Kotlin multi-platform. And spoiler alert, this is kind of my preferred method. So Kotlin multi-platform. So Android engineers, so as many of you know, some time ago, Android engineers used to write code in Java, and iOS engineers used to write code mostly in Objective-C. But then these languages kind of became outdated and difficult to deal with and difficult to update and so on and so forth. And so JetBrains built Kotlin, and Google adopted Kotlin as the official language for Android development. And Apple built Swift, which is now basically the official language for iOS development as well. And they're significantly easier to use and work with and so on and so forth. Kotlin multi-platform is basically taking Kotlin and building it natively on both Android and iOS. On Android, that's what happens anyway. On iOS, what happens is the Kotlin code gets compiled into something called an IR format, which is just an intermediate representation that then goes through LLVM and builds native code. Just kind of as an aside of how it works, but the takeaway here is that it's fully native. Like it's fully native, just like the C++ approach is native, and it doesn't go through any intermediary. There's no code, there's no like bridge that you have to go through or library or something else that you have to ship to kind of interpret the code or anything like that. It's completely native. So that's the first pro. It's completely native. The second is it's very easy to learn for engineers who are doing Swift. And the reason I say Swift is because if you're sharing app between iOS and Android developers are writing Kotlin anyway. And so for Android developers, writing Kotlin multi-platform is a matter of don't use certain libraries and don't use certain things, which is very low overhead for Android engineers to adopt. It's almost like it's almost a negligible overhead. But for iOS engineers who've never worked with Kotlin, the reason I say it's very easy for engineers learning Swift is because the languages are very, very same syntactically. If you saw both side by side, it's, at a glance, without knowing both, you'd be like, these are saying the same, like it's obvious that they're saying the same thing, right? There's another benefit of Kotlin multi-platform, lots of third-party libraries for both, for a lot of the things you want to do. It's backed by reputable companies, so it's built by JetBrains. Google backs it as well, but Google doesn't own it. And I think this is a nice thing also, because if Google owned it, it would be a harder sell for an iOS engineer to kind of ship some technology that Google is building, because like, I don't know what it could be, something weird could happen in the future, something like that. But given that it's backed by JetBrains, or JetBrains owns Kotlin and they made it, and it's theirs, then it's kind of more trustworthy, and people know JetBrains from all the IDEs that they built. They have a good name in the developer community. IntelliJ, Android Studio, a lot of these tooling is all built on top of JetBrains tech. And it supports a plethora of platforms. So I can build an app in the same code base and share logic with, not just with Android and iOS, but also with web, with Mac, with Linux, with desktop, with command line, and so on and so forth. Some of the cons of Kotlin multi-platform is iOS interoperability today is with Objective-C instead of Swift. So what that means is that the native code that is generated is Objective-C native code, not Swift code. And why that matters is it doesn't matter at a runtime, from a runtime perspective, because again, like the iOS developers are writing both Objective-C and Swift, but it matters for the niceties of using the API. So some of the features that are there in Swift, for example, exhaustive enums, that are not there, that might not be there out of the box, or I don't know, they don't work out of the box exhaustively. They work, but not in an exhaustive fashion when you build KMP. And of course, there are workarounds for this and ways around it, and it's on JetBrains' roadmap in the future to kind of directly allow interoperating with Swift. But the second one is convincing iOS engineers is still difficult, because a lot of engineers don't feel comfortable with non-native, with things that they perceive as not native. And for them, the word native, of course, if it's not native at all, that's very, very uncomfortable. But if you even tell them something that's native but not built by, not the native way that you know of, there's sometimes some pushback and some difficulty convincing people. The tooling is not there yet. So it works, it's stable, it's stuff like that, but some of the tooling isn't there yet, so some things are a bit cumbersome to do. Specifically, for example, if you're trying to debug from an iOS app into Kotlin multi-platform code, that you have to do that using third-party tooling and stuff like that. So the tooling is not there yet, and it's still in the process of maturing. So okay, great. Which one? And again, it depends. It depends on your need. It depends on the use. If today you already have a team of engineers and they're all React engineers that know React very well, and you need to ship an app as soon as possible, maybe it makes sense for you to go with React Native. You know, if you can't hire native mobile engineers, maybe it makes sense to go with one of those. If you have native mobile engineers and you have to work on something very, very performance sensitive, where performance, every last bit of performance matters, or something which is super proprietary that you really want to protect the IP, C++ might make sense for that. But generally speaking, if you just for general application logic, Kotlin multi-platform is a good one to start with. So okay, what do I share? So if you wanted to start today and you want to start sharing code, I would highly recommend, one of the places I'd highly recommend starting with is analytics. Why? Because a lot of times you'll build a feature and people will say, hey, the product manager will come and say, hey, where do I find the data for this on Android? What's the name of in Google Analytics that I look for, or whatever, in Firebase, or whatever you're looking at. And then they go to the iOS engineer and ask the same question. So instead of that being different, having a shared library for this, make sure that the analytics on Android and iOS are identical. So the same identical events, of course, with the differentiation of this is coming from Android, this is coming from iOS, you need that differentiation. But having that kind of analytics being shared saves a lot of overhead, saves a lot of time for both the engineers and for product. And analytics is not a part that a lot of engineers are excited about. So when you say, hey, to the iOS engineers, for example, you're not going to have to write analytics code, that's actually a win for them. So they might be more likely to kind of give Kotlin multi-platform a try in that case. The other thing is business logic. And business logic, especially complex business logic, makes a lot of sense in Kotlin multi-platform. So imagine something where you have a state machine, or something that with a lot of states that can change. So think about even something like, going back to the checkout flow idea, the person goes in the shopping cart. What are their options? Well, if all their information is in, maybe they have a one-click button to purchase. But if some of their information is in, you have to do continue to buy. Then you have to check, are they authenticated or not? And if they're authenticated, you have to do one thing. If they're not, you do something else. And then, okay, they're authenticated, but do they have an address added or not? Do I show them a list of addresses to add or not? Or do they choose to add an address? Do they, and so on and so forth. You can see all the forks going. And to be able to maintain the state and what's allowed in one state and not allowed in the other, a lot of this, having the business logic there, not the UI, the business logic there, saves a lot of time and resources. And then maybe past that, maybe more. So you can consider sharing, for example, presentation logic as well. Probably not UI logic. I wouldn't recommend UI logic today. Maybe in the future that'll change. But today, not UI logic, like continue building natively in Swift UI on or in UI Kit on iOS and in Compose or Views. Don't use Views, but use Compose on Android. But yeah, okay, so pros and cons. Pros, you keep iOS and Android consistent, which is pretty important. Maintenance is cheaper. So a lot of times people think by building multi-platform that they're really going to get to save on the development cost. But really, in the long run, that might be the case. But really what you save on by building multi-platform is the first 2 points. You keep the different platforms consistent, and you make maintenance cheaper. And the maintenance one, especially for code bases that are highly changing, is a huge one. Because imagine if this piece of code is constantly being changed again and again and again, and bugs are being introduced, you don't want to find the bug on Android one day, and then like 2 weeks later someone finds it on iOS. Engineers have to take time, find out what the problem is, fix it here, and in completely in isolation, 2 weeks later it's fixed by iOS and vice versa. If you have one place and you maintain it in one place, you fix it once, it's fixed for both. Saves you a lot of time and energy. Some of the cons might be more expensive initially because, of course, there's a learning curve. How do you do the interop? Until you get to a good way of doing it, it's initially going to be more expensive. I mentioned before, it might be difficult to get buy-in from iOS engineers and the interoperability with Objective-C instead of Swift. Okay, so not about code. What else should we share between platforms? First and foremost, vocabulary. So terminology. So for example, what you call different features or different screens or different flows. Keep these kind of namings consistent because it makes conversations a lot easier. And more importantly, make sure you're talking about the same thing. Because we've seen this happen where we had a concept that was completely obvious to us as Android engineers what we're talking about when we talk about that thing, and to the iOS engineers it was completely obvious to them what they're talking about, but there was a disconnect, and there were differences in what the Android engineers perceived and what the iOS engineers perceived. And so that's why I'm saying keep the vocabulary consistent. Keep the features consistent as much as possible, unless, of course, you're doing an experiment where you're saying, oh, I'm experimenting with this new thing, let me test it on iOS and experiment with this different thing on Android, and then if it works well, I'll port this Android thing back to iOS, and I'll port the iOS one back to Android, and so on and so forth. Architecture, maybe not early on, but as the company begins to grow and has more and more engineers, it makes sense to start thinking about a common shared architecture, so that engineers in one part of the app are not building in a completely different way than in another part of the app. And also to make it easier for an engineer that's working on, say, one part to be able to be easily migrated to work on another part without all the high cost of doing so. Another one, which actually is better done earlier on than later on, is a design system. And so what I mean by that is that today, usually what happens is designers will give the engineers some sort of Figma document or some sort of Photoshop, whatever they're giving, of how the specs should look like. The engineer goes in there, they add a label, oh, text size 13, font, blah, 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 bold, semi-bold, medium, whatever, and color this. What happens? A couple of weeks later, another designer is building a feature and it's like, oh, instead of making it green, let's use green, yeah, but let's use this different tint of green, and so on and so forth. What I mean by the design system is you never, ever go in and say text with font and this and this. No, you have a shared library components that you use instead. Oh, this is a company title. This is a company subtitle. This is a company error message text or something like this. And all of the things you're building are building from these. So you can see how it saves a lot of time for engineers. Instead of having to go and copy the specs one by one, they say, oh, this is just the title, subtitle, blah, blah, blah. But you can also think about how this saves time with the changes that are happening on the platforms. So Apple and Android a couple of years back said dark mode there. Someone who has a design system that everybody's using can just enable dark mode by enabling it in the design system, and then suddenly everybody has dark mode. Whereas if you don't, you have to go through every single feature one by one and make sure that everything works well in day mode and everything works well in night mode. Another one, versioning. We've been doing this for a bit, and it's actually pretty helpful. Keeping the version numbers consistent between iOS and Android. And it kind of helps for communication of features. Oh, we shipped out this new feature. When? In version 12.20, something like that. So people don't need to say, oh, you mean on iOS or on Android? Oh, on Android is 135, and on iOS it's version 300, whatever. You don't need to do that. And then finally, the release process. And what I mean by that is the release train, specifically. So how often you release, and things like that, which is a good segue to CI/CD. So CI/CD stands for continuous integration, continuous development, I think. But basically, it's the way that we ship code to production. How do you ship code to production? So really, the kind of the motivation and the goals here is production issues take time. Take time to debug, take time to solve, and so on and so forth. Time is money. And catching mistakes early saves time and money. And so CI/CD is kind of your defense mechanism for figuring out issues before you actually have shipped an app to production, because the longer it takes to discover an issue, the more expensive the fix is, right? And you can imagine an app rolled out, finding an issue that's been there for 3 different versions. It's very difficult to fix. Not so much even from a code perspective, but from how do I fix all the customers that were affected by this bug? Or if it's a loophole, how do I patch against this loophole when all these people have this old version of the app, and so on and so forth. So okay, so in talking about defense mechanisms, the first is code review. And that's, hopefully all companies have this set up, but if not, this is the first thing that any company should do. And the idea is that no code should be merged into a repository without someone else from the team reviewing it first. And the reason for review is it's not a performance thing. It's not something for like, oh, you're doing your job or not. No, it's not that. It's because we make mistakes. And some of them are very obvious mistakes, but we just miss them completely. Sometimes some of the things that I will see, people will see in my stuff is like, oh, maybe you accidentally left some logging statements in the code. A very harmless thing. Doesn't break the feature, but it's there, but it could be harmful, right? Someone looking at the logs could get some sensitive data, for example, so on and so forth. So code review is your first kind of line of defense. The second line of defense is tests. And having some kind of automated tests to catch issues early make things a lot easier. And tests, you can have kind of unit tests, which test some sort of business logic or some specific set of business logic. Integration tests, which test groups of business logic together. And then kind of on-device tests, on-device integration tests or UI tests, and screenshot tests. And the reason I explicitly call out testing here is a lot of what happens earlier on in companies is companies will have dedicated QA engineers. And they'll say, okay, once the engineers are done writing the code, we'll give the build to QA for a couple of days to play with. They'll find any issues, they'll report to the engineers, and then the engineer from there can kind of fix issues and whatever, and we can kind of iterate on that to release. But like we talked about earlier, this is one of these kind of process bottlenecks that slows down shipping, and you never actually ship in the amount of time that you intend to because of this case. And so really the ideal goal here is to be able to ship from the trunk branch or the main branch or the master branch, whatever you want to call it, of your repository. You want every single code commit to be shippable as it is. And this way you can cut frequent releases. And so you can repeat that cycle that we showed at the beginning very, very frequently. You can have 1-week release cycles, ideally. On backend, some companies do daily release cycles. Other companies do hourly release cycles. The more frequent these releases are, the better it is for a number of reasons, right? First off, and one of the things we saw firsthand actually was initially in the earlier days of Careem, we had one of our products that was shipping once a month. That was the agreed upon cadence. And at the end of the month, people would review the features and see what happened, and let's decide whether to ship it out or not. And usually what would happen is a month is a long time. And so then a product manager would come and say, hey, but I have this feature and it's just done. I need 1 day and it's business critical and I can't wait a month. We have to get this in. It's business critical, and then you can't push back. And so you end up saying, okay, we'll wait a day. And then by the end of that day, QA has found some issues. Okay, we'll fix those issues. Okay, blah, 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 blah. And then you ship every month and a half instead of every month. How we solved that was we came and one day and we said, okay, we agreed with the team that we're bringing this down. A month is too much because it's always more than a month. We're going to reduce it. And yes, we want to reduce it to 1 week, but 1 week is too ambitious today. Let's do 2-week cycles initially. And so we said, okay, you know what? The new release cadence is every 2 weeks. We made that call and we set it. Right before the first release, product manager messages me. Says, hey, Ahmed, I have this. It's critical. We need this. Like, I can't wait. I was like, I'll get it in for you next release. He's like, I can't wait. And it never ships in time. I was like, I give you my word, it will ship on time. And he was like, okay. Sure enough, the next release, we shipped it on time 2 weeks later. The point and the reason I explicitly mentioned the part about I give you my word is that it has to be a train. A release train has to be a train. It cannot be a bus. If it's a bus, you lose credibility. And once you lose credibility, forget it. Everything's out of the window. Because everything is business critical. Everything is absolutely important. Everything is like P1 priority. And so, so people will come to you and say, hey, I need this. I can't wait. No, we're shipping in a week. And we've had this. We still have this until today where people come and we say, we'll get it for you in a beta tomorrow. Customers can, the people in the company can start using it tomorrow. And people can start beta testing it tomorrow. We'll ship it to production in a week. And people know that that's the way it is. And so unless something is like so high priority that it's overruled by the CEO level, you don't have these problem of last minute additions to the code, which cause you grief that, that's hard to kind of solve later. So in addition to code review, and you have a set of automated checks that kind of helps you find out the kind of issues that are there. There are linters built in. On Android, there's Android lint, there's Swift lint. On iOS, there's a bunch of other ones for finding different types of issues and faults in code. These are really useful. Run these. They catch a lot of the common mistakes that people make. People have kind of written rules to warn you or fail your build altogether if you make one of these mistakes, so that you can address it before it's too late. A code style enforcer. So one of the things that we've seen sometimes when you open a pull request, some engineers who review it are like, they come to review it and they give you very annoying reviews, which is basically like, why are you using 3 spaces here when we're supposed to be using 2 spaces? Why did you leave a new line here instead of, like, man, I want you to review the content of the PR, not how many spaces I put in front of the word. But of course, this styling is important, so enforce it with a tool. Don't waste engineers' time writing and telling you, hey, you have an extra space here, you left 2 new lines instead of 1, blah, blah, blah. Like, don't do that. Code smell detection, you have other tools that will analyze kind of the code and kind of tell you like, hey, this method is too complex. It has too many lines of code. It's not good enough. Or this method doesn't have enough code coverage. Maybe you're not testing the all the different branches well enough. Things like that, right? The next thing I'd advise in CI/CD is exposing hidden changes early. And so what I mean by hidden changes are changes that are not at all apparent, obviously, of course, but that actually have a potentially profound impact on the binary that you're shipping to Google or Apple. The first is transitive dependencies. And what that means is I add this library for Firebase. And Firebase has its own dependencies. And so it adds these kind of transitive dependencies. Usually this is okay, but sometimes it's not, especially when you're talking about using libraries that are older, that might be pulling in a very old version of something, or might be pulling in a version where there's going to be a conflict with the version even a newer version than what you're using internally, and it could cause breakages, and it does. And unfortunately, depending on how you're building, some of these breakages you won't find out except at runtime. So on Android, especially if you've already compiled, if you compiled against version 1 and you're running against version 2, the only way it'll run cleanly is if version 1 and version 2 are binary compatible. If version 1 and version 2 are not binary compatible, you'll build your APK or your app in general, but when you run it, you'll get a runtime crash because it can't find the code that it's expecting to find to be able to call. The next one is binary size. This one's a really big one because, so a bunch of companies did some studies on this, and they found that increasing binary size, it's actually kind of funny, actually, to be honest. Like, I was shocked, but kind of, it's amazing the ingenuity of some of these companies and what they're testing. So on Apple, for example, so the limits on Apple and Google are different, right? On Apple, there's no real limit, but there's a limit for what the size of the app can be so that you can still continue to download over 3G, or sorry, 5G, over mobile network. And if you go above that, you need to like grant permission to be able to, I think it's 200 megs. If you go above 200 megs, by default, it'll only want to update on Wi-Fi unless you explicitly go and try to update the app, and then it'll say, hey, are you sure you want to do this? And then you say yes, and then it goes through. On Android, there's a soft limit of 150 megs for an app bundle, for the core app bundle, something like that. And of course, you can extend with data and other stuff there, and they give you other ways to extend, but you have this 150 meg limit is a hard limit. And that's at the most. If you're still not on app bundles, then that limit is 100 megs. But I think everybody will have to be on app bundles sooner or later. So the funny story was, one company decided to test this on Apple. So they added random stuff to their app that does absolutely nothing, just to bloat the size to above 200 megs. And just shipped out a little bit to some of the customers, just to see what would happen. And they actually saw a drop. They saw a drop in the number of conversions, in the number of installs, which is pretty surprising. And to me, the surprising thing was like, man, who would actually think to experiment with something like this, right? And similarly, they have numbers similarly on Android that with every, I think in general, both on Android and iOS, with every 10% increase, you have X% decrease of people who are using it, of who download it. Another one is permissions. So Android has permissions. Do you use camera permission, audio permission, blah, blah, blah. And sometimes what happens is you get a permission added that you had no idea was being added because you added a library. So for example, you add a bug tracking library, and suddenly the phone now wants permission to record your microphone and control your screen. Why? Because you can take a screenshot and you can like record some audio about what the bug is and send it up. But maybe you don't want to do that. Maybe you don't want customers to have to deal with this. So exposing these kind of things, again, you might not see it because you might not try the bug tracker when you're testing the code. Release early, release often. We've talked about this. Another one is staged rollouts. So both Android and iOS have this option called staged rollouts, which is when I come to push a new version of the app, instead of pushing it to 100% of the people, I can push it to 1% or 5% or something like this. Use these. They save a lot of time and energy, because even if you save 5%, it's not like immediately 5% of the people have your app. It's 5% of the people are eligible to start updating to your app, and within a couple of hours, some people would have within a day, 2 days, 3 days, 5%. Probably you'll have 2% or 3%, something like that. But the nice thing is, if you've shipped something to say 5% and you find a crash, and maybe that crash is happening a low number of times, but given the percentage that you've shipped it out, that's actually a high number, because maybe the crash happened 5 times, but you've only given to 1% of the users. Maybe 5 times is a lot for 1%, especially if you just started rolling out. Then you know that like, oh, I need to address this issue. And the nice thing is, if you address it and you roll out a new one, the same 1% that got the patch, that got the first one, will get the second one as well. And so you can kind of limit the scope of the impact radius of bugs to a smaller percentage of people. Another super useful thing is a beta program. So it goes without saying, enforce, like if you don't do this already, enforce that all employees must use the beta build, or the development build. This is very, very important. So what we do, for example, what we've been doing at Careem that's worked pretty well for us is we have a public beta. So anyone can actually join the public beta. And we ship this beta every night. We have a nightly shipping almost every night. probably every weeknight, something like that, of the beta build. And so every night, so the people who are using a lot of this is the Careem employees, right? To when they're ordering food or when they're ordering rides, they're using it. And if there are bugs, we've given them a way to complain and to tell us about the bugs. We can find them and we can fix them before we actually ship out to production in general, right? And everybody who's on the beta build is either an employee or someone who has explicitly opted in to be on the beta, so they know how to kind of opt out of the beta if they need to in general. And that helps you catch issues earlier, and again, catching issues earlier saves time and money. Switching gears, I want to talk a little bit about engineering culture. So I think this is really relevant, even though it's more of a kind of a soft, like, it seems like, why are we talking about this? But it actually makes a really big difference. The idea here is engineers are humans, obviously. Humans make mistakes, and blame is bad. Blame is not productive. But learning from mistakes is productive. And the reason I say this, it sounds obvious, but unfortunately it's not. And one of the stories I really, really love, one of the things that have kind of shook my world kind of thing when I heard it, when a lot of these companies have onboarding when you start working there. So in Facebook's onboarding, you have a couple of weeks where you kind of learn how to commit code and do this and that, and they teach you about the systems and so on and so forth. They told us a story, and that story, I keep telling people about the story because to me it was insane. They said on one of the first, on one of the kind of these orientation sessions, they had some sort of developer exercise where you would make some site and you would push it to production, and you can see your site there live on Facebook to kind of show people how to commit code. One engineer did something, made a mistake, and took Facebook.com down. And now when we talk about taking Facebook.com down, you realize that every second, not every minute, every second is probably millions of dollars lost in advertising revenue and so on and so forth. It's a calamity. They took Facebook down for 3 hours. So they're like, new hire, brand new, second week. So they're like, what do you think happened to her? I'm like, man, you guys fired them. Definitely fired them. Like, they're like, why would we fire them? They made a mistake. Anyone can make this mistake. The question is not why they made the mistake. It wasn't malicious. The question is how could we have prevented it? And so instead of firing the engineer, they understood why exactly it caused the issue, and they built fail-safes into the system so that anyone who does the same mistake in the future, they won't take the system down, right? And so that's what I mean. A lot of, unfortunately, in some parts, people make mistakes and it's the end of the world. And people are afraid to admit their mistakes. No. And especially engineering leaders and companies should actually do effort about this, which is admit when you're wrong. We're all humans. None of us is an angel who will never make mistakes. Admit when you made a mistake, when you made a bad call, and talk about what can we do to make it better. When an issue happens on a team, and especially engineering managers, instead of saying oh, this person on my team is responsible. No, it's not about who's responsible on the team. How do we fix it? And if you want to take blame for yourself to shield your team. And that's what makes stronger teams. When the engineering manager kind of shields the team instead of kind of trying to undermine the team. The next one is build ownership. And what I mean by this is a sense of ownership. When engineers have a sense of ownership and feel that the product is theirs and they care about it, they will go out of their ways to fix things that you didn't even ask them to fix. But they see something that's wrong to them and they go and fix it. And I see this day to day. This is a real thing that myself and other engineers do, where we're even to the extent of I'm contributing some patch to a different repository that I don't usually work on, but I see something and it bothers me. It suddenly starts bothering me. It's kind of like I like my room clean, but there's this garbage on the floor. I'm going to pick it up and throw it away. It's the same exact thing. Building ownership is very, very valuable, because then your engineers kind of look for what's wrong and try to fix it themselves and propose things to fix and so on and so forth. Hire good engineering managers. We touched on that before. Give developers good hardware. Again, we talked about this a bit before. Keep learning and improving. So always kind of get feedback from other engineers that are working and understand kind of what they've done and what they like, what they don't like, what's working in the process, what's not, and so on and so forth, so that you can kind of continue iterating and improving. A lot of companies actually do these surveys where they kind of like, for all the employees, anonymized surveys for all the employees to kind of understand what people are happy about, what they're not happy about, and so on and so forth on a regular basis, to kind of get this idea. And when people complain about things and they see that leadership of the company is actually making an effort to change it, that makes people feel more like they're being listened to and heard, which helps your retention and helps your company morale and helps the execution. It helps a lot of things. And finally, I'd say focus on impact. And so idea here, basically, all of us have 100 things to do. Which one should I do? Think about which one will have the most impact, the most positive impact. Focus on that. That's all I got. Thank you. Please.
In the very beginning, we spoke about process bottlenecks, the number one being company release process.
Yes.
And then you kind of touched upon different kind of release processes and tips on how to make that a little bit more seamless. But if there were like, how many steps to a release process should there be? Is there anything we should definitely be avoiding? Anything that really works?
Yeah, I think that's a good question. It's difficult to give a like a one size fit definitive answer, but at least some thoughts about it. Some of the things that we've done that has helped us out a lot, tremendously. First off was automating. So I mentioned the story like a little bit about how we went from 1 month releases down to 2-week releases and how that made things easier. I left out a part, which I will now bring in and talk about also, that also made a difference, which was back then, when we had these 1 month releases, we had dedicated QA team. But at the time, because of something was happening, somehow we lost our QA resources. And so then when we moved to the 2 weeks release cycle, it was at the same time we lost these QA resources. And that suddenly put us in a big problem, because now, how do we know that the app is working or not? We were trying to get management to give us new QA resources, but they're like, I don't know, we don't know if we can right now or not. We have to wait. So initially what we did is we had, basically QA had this large sheet of all the kinds of things they test in different parts of the app. And what we did is we said, okay, we're splitting this sheet up across the engineers. Every engineer is responsible for this subset of tests. And on every single release, every 2 weeks, engineer has to test and give a green light for their tests. And of course, what happens is engineers hate doing this, but that's the expected. And so what happened is engineers started writing tests. Then they say, oh, does the test pass? Yes, it passes. Okay, it works. The test says it works, it works. And so eventually what happened is we automated all these tests. And that removed the whole friction from the process and give us more reliability. And it was that step that we took that eventually in the long run allowed us to move from 2-week release cycles down to 1-week release cycles, while feeling pretty confident about it. A lot of one thing I don't like that I've seen a lot and still happens, and I understand why it happens, but I personally don't like it, is that sometimes people are hired as specifically as QA engineers, meaning like, okay, you're an engineer who knows how to write code. Your job is to test the code of the developer and write tests for the code of the developer. To be honest, I don't think this is the way that it should be. Engineer who is writing code should test their own code, should write tests to write their own code. There are even some perspectives and thought processes that you should actually write tests first and then write code later. Irrespective, even if you don't adopt to that, it's still, the person writing the code is the person who knows how to test it the best and should be able to test it with the aid of some tooling to tell them, hey, you're missing this kind of branch here, that you're not testing this case, this condition. So I guess, yeah, the first thing is automating as much as possible. And when I say automating, I'm not just talking about tests. I'm also talking about the release process itself. So another example that saved us a lot of time, and we should have done it earlier, but we waited too long to do it, but we finally did it, so better late than never, is automating some of the things that happen in a release. So what happens in a release? Oh, you need to change the version number. You need to update the README. You need to push the app to the store. You need to... So there's a huge step of things there's a laundry list of things that have to happen. All of these things are manual processes, and some of them are error prone. You might accidentally do the wrong branch, or you might push the wrong tag, or you might do this or that or the other. So we kind of automated a lot of this stuff now, so that even the release itself is kicked off by an automated process. So we have a process that, say, for example, every Monday morning at, for example, noon, will kick off a build for the release and prepare it, and it's there, and someone just needs to review and look at the changes that have happened. By changes here, I don't mean PR changes. Of course, every pull request is reviewed separately, but what I mean is, at the very end, right before we release the app, we take one final global view of what happened in the kind of global app. Not talking about the code level, I'm talking more about what dependencies have changed, what happened to the application size, the binary size, between last release and this release. Because sometimes between two pull requests, oh, this one increased it by 50K, and this one increased it by 50K, and this one increased it by 50K, and you don't notice 50K. But then when you come at the end and you say, oh my God, it increased by 1/4 of a meg. Where did this 1/4 of a meg come from? That's a good time to kind of catch it and flag it and try to figure out and understand before it's too late. So automating that has saved us a ton of time, because then now your release becomes a one-button release, or just a matter of like pushing a tag, and that's it. Everything else is done for you. Yeah, so basically, I guess those are the two things, right? Have trust in the code. Be able to trust the code that you ship that's merged. So whenever the code is merged, ideally you should be able to, ideally you should be able to release every day. It's not practical to release every day to production for mobile apps because of the app review process and all that stuff. But you want the code to be in a state where any day you can just cut the release and ship it. So that means if you're working on some feature that you're not done, make sure that it's not visible, that it's flagged and it's turned off until it's done. If it goes into production when you're not done, you don't need to revert anything, you don't need to change anything, it's turned off. At the code level, no one can actually even see it or use it. Something like this. I don't know if that kind of answers. Oh, and the data part that I said at the beginning. That's also really important, because that data part helps you figure out if something went wrong that's not apparent at all. Oh, and one thing I forgot to mention, like of things that you should measure, is the whole thing about performance as well. And so a lot of times we don't really think about performance until it's kind of too late or too big of a problem and too difficult to solve. But keeping aware of performance from earlier on makes a big difference, because again, companies have done studies and seen like for every 100 milliseconds you add to the time of reaction of blah, 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 the percentage of people who go through and continue using the app decreases by blah, blah. There are actually studies about this. And so especially for sensitive things, the launch time of the app, how long does it take for the app to become launched and usable? For the launch time of critical features, if you have to click and wait 3 seconds for the feature to become usable, you can imagine that you're going to lose a lot of people in those 3 seconds, right? So being aware of those times, monitoring them, and also the tricky part is, ideally if you monitor them, you would know, because sometimes the things that cause these numbers to go up are not obvious. They're only obvious in retrospect. So for example, maybe a network call. Someone adds a network call somewhere, and they make that network call required to render this content, for example. And maybe that network call is really slow. So also even network calls and stuff, having some kind of idea of how long these network calls take, what is the latency, and so on and so forth. All of these things will help kind of make sure things are in good state. Please.
What's called text experiments within micro team? Is there like a checklist that you can use? You have like small, or you have like test experiments?
Yeah, so I think for smaller teams, a lot of this will be word of mouth between the kind of product managers or engineers on the team, depending on the feature. One thing that we've done is we've kind of exposed an ability to override experiments inside the app only during development. That might help. So meaning that if I'm on a developer build and the person using it is an employee, maybe I can tell by something, by set of allowed user IDs or by email address, host name, or something like that, that this person is an employee, then I can allow them to directly override the experiments, and they have a list of them. And so if we name the experiments properly, then maybe I search for profile and I see, oh, I'm running an experiment called profile X, but there's also one called profile Y. And then I go and find out who the owner of that is and ask them and make sure that there's no conflict there. So maybe I think that's one thing that helps. But other than that, it's just communication between engineers and product to kind of be aware of this. I think at some phases, like at much larger scales, there's probably some way to kind of automate that as well, in the sense that I think company at Facebook scale, I think what I remember is they actually could predict, you create a new one, and after it runs for a while, they predict what other ones it might affect or impact, or which ones it shouldn't be run in parallel with, or something like that. Or at least they give some way for you to say, like, oh, this is related to this area of the app. And so then it shows the other ones related to that area that are currently running today. So I guess if I may ask you a question back, why can you not give them the whole code? Why can you not give them the whole code? So I think sure. To be honest, I don't know. So for example, like a lot of the companies I worked at, pretty much all the companies I've worked at, the entire code base was open for everybody working on it. And then kind of permissions are given for, for contractors or something to only get specific portion of the code or specific repositories or something. I guess if you have to do that, probably you can separate out whatever they're working on into a separate module and a separate repository altogether. You can consume it as a library in the code and have a sample app that mirrors what your real app is doing so that you know how it works in practice. But I guess aside from that, there's probably legal ways to protect yourself when signing a contract, blah, 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 so that the person can't just take the code and do something with it later on. But if without having that as a fallback, then your best option is to kind of separate out into a completely separate repository altogether and only give them access to that repository, and just have enough integration points and integration testing or in place that you know that if it works in their code, it's going to work in your runtime environment with a high degree of certainty. Not specifically I guess it's not specifically a platform thing per se. It's more of a process you're going to be building in-house and a sample app that you're going to have attached with it. Does that make sense? Or the contracts. Maybe it's a matter of contracts, and what I mean by contracts is not legal contracts, but even code contracts. So for example, you say, okay, you're building a profile screen, and the only input I'm giving you, I'll give you the interface of how this looks like and how I'm passing you the customer object. And I'm giving you a call to update phone number and update blah, blah, blah. And I'm giving you with it a stub implementation that doesn't do anything, or that stores everything in a temporary, just in memory right there. And it doesn't go into a backend or anything. So if it works with that, chances are it'll work in production. Chances are. Maybe not, right? Because maybe, you rely on the fact that the sample is synchronous, but the production one is asynchronous. Well, you can solve that. You can make it so that it waits a second to pretend like it's loading, and sometimes waits 5 seconds and then does it, and so it becomes obvious when there are issues. So the closer you can give them an environment, a sandboxed environment, and the closer that sandbox is to reality, then the more of a matter of drag and drop it is for you to just incorporate as a library. Please.
You are not like Spotify. How do I? What is the best platform to see what other big companies? Their culture.
Yeah. So there are you'll find a lot of resources online from different companies talking about their kind of manifestos or way of running teams there. I think in addition to Spotify and that article that I shared about Scrum and Agile that I mentioned in the slides, which would be really useful to look at, kind of tells you a little bit of some of the things that some of these companies think about or think through while they're doing these processes. I guess in general, what I meant by don't be Spotify is just don't just copy paste something you see online and try to incorporate it in an org and just hope that it works. Because chances are, just because it worked for them, it doesn't mean it'll work for you. And I'm not just saying that hand-wavingly. I'm saying it from experience. We've done that before, where at a certain massive section of the team where we said, okay, we're doing the Spotify model because the Spotify model sounds really good. And I'm not saying it's not good. It sounds good and the benefits are huge. So we're like, hey, it works for Spotify, it'll work for us. It didn't work for us. And that's because engineers are different, people are different, companies are different, processes are different, code is different, a lot of things are different. So what I'm trying to say is, like, take the learnings from what these companies have done, take the good ideas from here, the good ideas from there. What I would say is try it slowly. Don't try to roll out an org-wide, like, hey, everybody, we're switching to this way of doing things from tomorrow. No, try it out slowly. And I think that article actually talks a bit about this. Specifically he's talking mostly about Agile and Scrum, but he talks about this as well. Don't try to go one shot and like implement and just hope for the best, because typically these things are a massive failure, typically. And really what works is you start at a very small scale. You'll see some things work well, some things won't work well, and kind of tweak from there. And the other thing that he mentions, which is also true, is that the reason a lot of these big companies don't have an official policy per se, and they let teams decide for themselves, is because engineers like autonomy. And so processes in general, engineers don't like processes. I mean, of course, some process is necessary because you need to be able to know what's going on, what's moving, what's happening, what's not happening. Like, I'm not saying no process at all is needed, but the more the process, the more annoying it is usually to engineers. So limiting the process usually makes life easier for them. And so that's why a lot of these companies kind of leave it per team. Some engineers might really want the process and really want to see and have a board, a Jira board and or a Trello board that they see the tickets moving from one column to another, and that's fine. Other companies might be like, we're going to use GitHub issues and put our stuff there and have milestones, and we're just going to be committing towards milestones and stuff like that. That's fine. Every company works different. Try it out at a small scale, get the feedback from the engineers before scaling it out at large. I guess those are the only things I can say. Sorry, I know it's not but yeah. That probably is restricting you to? Oh, okay, restricting user growth. That's a good question. So a lot of the problems that we have today are probably around the fact that we have engineers working on different parts of the apps. So some set of engineers working on the ride experience, some set of engineers working on the food experience, some set of engineers working on the home experience, so on and so forth. And kind of bridging these gaps and making the app feel like one app, for example. So I want, for example, a unified design for everything. Doing it when you're building from the beginning is easy. Doing it after everything is built is very, very difficult. So that's kind of one of the things. Another thing might be building things that are cross-domain, per se. So I want something that allows searching, but is smart enough to search for, locations that you might want to go to with a Kareem, versus locations that are restaurants that I might want to order from, versus locations that are grocery stores that I want to order food from. And it's like, okay, but it's one app, it should be easy, right? But no, it's not that easy, because we don't want to strongly couple the apps together. And that's kind of part of the intentional design that we put in place. We've kept the mini apps separate, and it goes back to this modularization point that I made earlier on, which is the more modular the code is, the easier and the faster the build times are. So today, an engineer at Kareem working on ride hailing does not have to build the food app, and does not have to build the payments, and does not have to build any of the other things that we have. They only have to build the food app. And the one working on ride hail only has to build ride hail, and so on and so forth. So we decrease the amount of build times that it would take. Otherwise, they have to build everything to go. I'd say those might sound like they don't affect user growth, but they do, right? Because being more intentional about how you do these kind of integrations and doing it in the easy way to do the integrations is the direct way, where I'll go edit the code here and I'll go edit the code here and I'll add an API and like I'll tightly couple them together. But if we do it that way, we're adding technical debt, and we know that that's going to cause us problems as time goes on. And we know that's going to cause us crashes, and we know that we're going to have binary compatibility things to think about, and so on and so forth by doing that. And so being able to kind of synchronize across all of these is tricky. I think that's probably, I think, the first thing that comes to mind, I guess.
All right, I just want to give a big thank you to Ahmed for taking time out of his Saturday to give you guys this amazing insight into mobile development. You will be staying here a bit while, or?
Sure, I'll say shortly for
Okay, so
questions.
if you do have any more questions, you can still ask him. And we do have workshops next week as well. I think that will be based on user development. So if you are interested, you could come next week as well. We have the same time, we have another workshop. I just want to give one last round of applause for him.
Thank you.
Thank you.